All right. I'm actually going to walk through each and every problem because I want to make sure you have reason to square down.
We knew you were here.
Okay, we'll see at the end of the time.
Is that the girl you saw, Christian?
Huh? Yeah.
All right. Okay. So let's run through each of the problems. You stop me if something doesn't make sense. All right, so problem number 1, you get x squared. Is that minus 12x? Plus blank equals something squared. Okay, so all they're really asking you to do on this problem is, hey, can I figure out what number to plug in for the square that would be a perfect square trinomial? Okay, so let's do a couple things. I'm going to get x, and I'm going to get minus so far. So those two things have to match up. Good? All right, ready? This is how easy this is. Ready? What's half of 12?
6.
6. What's 6 squared?
36.
Done. Every time. Same exact one. So let's take a look at number 2. Number 2, we have x squared plus 5x. Is that what it says? Plus blank equals something squared. All right, ready? X comes here. This sign comes here. So what goes there then? That sign goes there. Where does it go? Where goes there? Less. Half of 5 left as a fraction. Half is 5 left as a fraction. 5 over 2. Okay, that's half of 5. 5 over 2 times 5 over 2, or 5 over 2 squared is? 25 over 4. Done. So if I were to take x plus 5 and multiply with x plus 5, I FOIL it together, I'd get x squared plus 5x plus 25 over 4. Number 3. X plus half x squared equals. All right. So this x comes here. This sign comes here. So that's a plus. What is half of a half? 1/4. Good. So I put 1/4 right here. What is 1/4 times 1/4? 1/16. So 1/4 squared is 1/16. So if I took x plus 1 over 4 times x plus 1 over 4, FOIL it together, I would get x squared plus 1/2 x plus 1/16. Good? Okay. So any questions on those first 3? Do you feel comfortable about that? If you were on Friday given that type of question, could you handle it? Yeah.
Will you ask us questions of fractions? Or where, like...
I tried to make them whole numbers.
So, like, will you ask, like, for example, with 5? Because it turns out to be a fraction.
I might give you 5 over 2. I mean, like the 5, you get 5 over 2, or 7, you get 7 over 2.
Okay.
I mean, that's all you have to do is just, what's half of a number? Make it over 2. What's half of a fraction? Double the denominator every time. Okay? Any other questions about these first 3? Feel comfortable with it? All right. Whoa. Okay, so let's take a look at the next ones. Number 4, so these ones we actually want to solve them. So I have x squared minus 6x plus 2 equals 0. Okay, so we want to complete the square. So the very first step, make a space. Good? So I'm going to make this right down below. This is the same thing I was just doing. The x comes here, and that sign comes here. What's half of 6? 3. What's 3 squared? If I add 9 and I add 9 to this side, is that okay so far? If I had FOILed out, if I had done that multiplication right there, that's my complete square. If I took x minus 3 and multiplied with x minus 3, I get x squared minus 6x plus 9. Okay? What should this 2 do? Subtract, right? So I'm going to get 0 plus 9 minus 2. Is that okay so far? So I have x minus 3, quantity squared equals 9 minus 2 is 7. The square root, don't forget plus minus. Can I break square root 7 down?
No.
No, it's going to stay plus or minus 7 right now. Plus or minus square root 7. So then I'm going to add 3, and this is my exact answer. It's done. If I had done the quadratic formula on it, that's what the answer would have been. Okay? So if you see the pattern of these, you're going to do quite well. Number 5. Can I do number 5, please? Any questions here? You have everything? No? Don't move it?
Did you use the quadratic formula?
Could have, but I want you to complete the square on it. Can I go to 5? Okay. Number 5. So see if you can hear the exact same terms that I just used. Is that plus 2x plus 5? First step. First step. Make a space. Okay? That sign also comes down. Half of 2. 1. 1 squared. 1. Agree so far? So I get that. Plus 5 equals 1. Subtract 5 from both sides. Agree? Root plus minus. What is the square root of negative 4? No, 2 times 2 is 4.
No.
There is no real solution. NRS. Okay. Is that all right? May I do number 6? Number 6, x squared minus 2x plus 5 equals 0. First step, make a space. Hey, what sign's going to go right here?
Negative.
Minus, yeah, that comes straight down. Half of 2 is 1. 1 squared is? Add 1 to both sides. Is that good so far? Subtract 1, or excuse me, subtract 5. Do I need to go further, or does anyone know what this answer is? Why is it NRS?
Because there's a negative.
Yeah, I have that negative. So once I've completed everything, if I go try and take the square root, this right here is going to give us no real solution. Okay, again, I can't take the square root of a negative number in the real number world. The complex number world, it exists, but we're not there. Okay, number 7, is that okay? Number 7 says x squared minus 4x. Minus 9. First step, make space. Talk to me, what goes here?
X.
What goes here?
Minus
What goes here?
2.
What goes here?
Plus
Plus what? Square.
4.
Yeah, that's always positive there. That's kind of cool. Okay, minus 9 equals 4. Is that okay? Feel comfortable with that? What should I do next? Add 9, all right. Root, plus or minus, right? Can I break root 13 down? Nope. So what's my answer? X equals,
-2 plus
almost. What should I do with that to bring it over? What is that? If I move it over.
Plus
Positive 2, yeah.
X equals
2 plus or minus root 13, yeah. Okay. Okay, so these have all been equal to 0. Then we get to number 8. And number 8, we have this. But I think that's still okay to have. Because what do we do with that number at the end of all of our other questions? Yeah, we move it over, right? So I think this is okay. So we're just going to create a space between the 6x and the equal sign. X, what is here?
-3.
Minus 3 is half of 6. 3 squared is?
9.
So plus 9 and plus 9. Oh no, it's equal to 0. How can something be equal to 0? Well, 0 is a number. Alright, whatever. Alright, I'm going to take the square root. What's the square root of 0? 0. Is there a positive and a negative 0? No, 0 is signless, so you just line up with this. So what's my answer? X equals 3. Move the 3 over. Hey, we only have one answer here. Why is there not a plus or minus? Because if I do the square root...
Sorry.
Just kidding. Sorry.
Get her!
She's an idea.
I didn't mean to scare her off. Am I an unfriendly person? Just kidding. Did I ever tell you what happened during back to school night? So I had a mom. It was for my 6th period, but the mom came to my 6th period class, and I have up on the board, and this is way back in grade school. Hi, my name is Mr. Stirrup.
Oh yeah, you told us this.
And you would think that parent would look down saying, you know, okay, Algebra 1, Mr. Stirrup. No. She sat my whole thing, and then she came in and yelled at me because her son was doing poorly in my class, and I'm looking at her kid going, I have no idea who the hell your son is. And the kid looked at his mom, that's not my math teacher. Then the mom says to me, why then did I sit in your math period during back school night? I'm thinking, maybe you're an idiot? I have no other, because I was grabbing random parents like, hey, come on in. I know I don't teach your kid, but see me. I don't know why that popped in my mind. Those strange things that take place in Stirrup's mind. Hey, so again, this only has one answer because that plus or minus 0, it's just one component. And then the last problem, number 9. Number 9. X squared plus 8x plus 12 equals 0. All right. Space. What's here? Plus 4 squared. 4 squared is? 16 squared. 4 times 4. Right? Is that okay? What should I do next? Subtract 12. Cool. Root. Don't forget the plus minus. What's the square root of 4? 2. So then I get x equals -4 plus or minus 2. Do the arithmetic. -4 plus 2 is negative 2. Negative 4 minus 2 is negative 6. There's my answers. So sometimes we have an answer that's a root. Sometimes we have an answer that is just single because it's the square root of 0 first off. Sometimes we have whole numbers. Sometimes we have a no real solution. Okay? So I want you to, did everyone write down every problem?
Yeah.
If you're here, I'm going to go ahead and put the points in for you. So put a 4 at the top. Because I want you to help keep that out. But I want you to flip it over to the back side. And we're going to take a look at a singleton type of problem, and we're just going to walk through it. And I think it's something that we can figure out. Thank you, much, sir. Get some more?
What?
Did you get some more?
No, I don't know how to do it.
What? Okay, so let's say I give you this equation. Okay. So, and this is acceleration of gravity. Okay. So let's just kind of make up a story. You ever been on top of a tall building? Did you ever want to like flick a pebble down? No. Makes it normal. You know what I did when I went to the top of the Empire State Building?
You put your pebble and it hurts them.
Penny.
Those are lethal.
No, there's not.
Yes, there is.
No, it's not.
What's lethal?
It's not.
Penny.
Like, it visually myth busted about
Proved it right.
No, it doesn't hurt them at all. It didn't hurt them at all. It was like a little
If it was right, then I took somebody out of the equation back in 1978.
There's also a very
You're a murderer.
Maybe I'll meet one of your parents. Someone's got a big old dent in their head. What happened to you? I was walking around New York City, got hit with a penny. Oh, sorry.
Wait, did you hit someone?
I have no idea. I was like 1,100 feet up. I couldn't. I was like, and you see. Didn't see where I went.
What if you were to drop a toothpick?
Do what?
What if you were to drop a toothpick?
Toothpick?
Wouldn't it like kind of slowly just fall?
What if you drop?
Toothpick doesn't have enough mass to. The terminal velocity of the toothpick is not going to.
What if you drop?
What if you drop the bowling ball? Well, that's different. Different size mass.
So fast.
All right, so let's say we are on top of some tall building. Woo-hoo, we're up here, yay. I don't know what building it is, and I don't know why we're jumping off the ground. Maybe we should put some feet on you. You're still jumping off the ground. Maybe you're on this platform. Okay? And let's just say, for all intents and purposes, you decide to take a ball. Take a ball and you toss it up in the air, and it comes down. Still with me? So let's say from the height that you threw and on top of the building, let's say we're talking about 8,000 feet. Okay, 100-story building. Okay, call it anything we have here, and call it a 100-story building. If you go to Chicago or New York, come across a 100-story building, so 1,000 feet. Okay, and that includes the height of you throwing it. So maybe the building itself is 995 feet in your arms, or 994 feet if you're 6 feet tall. I don't know. Okay, so our original height, we're going to put it 1,000 here. Still with me? Okay. Now I'm going to throw by me throwing the ball up into the air. I have a positive velocity because I'm throwing it upward. If I threw it downward, I'd have a negative velocity, but I'm throwing it upward. And if I just dropped it, I'd have no velocity. It just has acceleration. So positive velocity, and let's say I throw it at 10 feet per second. That's my That's my positive original velocity. So that means I'm going to plug in a 10 right here. Still with me? Does this seem like something somebody could do? Whether this ball is going to strike somebody or not, I don't know. Okay? All right, so a few things I want to know. I want to know when it is at maximum height. And then what is max height? Okay, so this is when, and this is what, which is x, and that is y. What would this appear to be as far as a parabola? What's that really high point called? Apex? Kinda. Maximum? It is a maximum? Well, what is the actual point it called? Vertex! Yay! So I have a vertex here. Okay, I have a vertex. Okay? So, let's take our equation that we have here and let's kind of put it into our version. So y equals negative 16x squared plus 10x plus 1,000. Is that okay? That's a little more, that's user-friendly-er. Okay, how did I find the vertex? Back a while. How did I find the vertex? How do you do that? X equals negative b over
2a.
Yay! Negative b over 2a. Good. And so my a value is negative 16. My b value is 10. My c value that I don't need right now is 1,000, right? So if I get negative 10 over 2 times negative 16, that gives me, I gotta ran out of room, sorry about that. So that's gonna give me 10 over 32, is that right? Which I can reduce to 5 over 16. So that's the x component of my vertex. And that's not real friendly. It's a little bit less than half a second. So this is what this means in the context of this problem. If I was standing on top of this building and my arm is 1,000 feet up and I threw a baseball or a ball of some sort with an initial velocity of 10 feet per second upward to fly over the edge of the thing, because I had to throw it upward, I had to go over the fence. At 5/16 of a second after I released the ball, it made its maximum height. That's less than a half. It's less than half a second. It's quick, isn't it? Well, I mean, in the context that we did, I just made up this off the fly. So, I mean, there might be some problems we do. It's like, oh, after 3 seconds. But because I made this up off the fly, we came up with 5/16 of a second. Yikes. So let's just, for all intents and purposes, call this, I know this isn't real, right? But let's just say it came out to 2. We're pretending it came out to 2. Is that okay? How would I know what the maximum height of the ball was? If, let's pretend, because I don't really like this, let's pretend this is our answer. How would I find the maximum height then? Plug it back in. Now, I don't want to plug 5/16 back in because that's kind of gross. So I'm ignoring that for now. We're just pretending this came out to be 2, okay? So if that came out to be 2, if I take that 2 and plug it back in to my original equation I know is this. So I'm going to take that 2 and plug it in. Is that okay? I subbed that in. Now I realize I could have done the 5/16, but let's face it, we're not big friends of the fraction. All right, so let's see if we can figure that out. Negative 16 times 4. Is that okay so far? Plus 20 plus 1,000. That's negative 64 plus 20 plus 1,000. So that's negative 44 plus 1,000. And this is going to be off a little bit because what did I do with my problem? I changed 5/16 to 2. Bless you. So this means that at 9:66? 9:56. So at 2 seconds, I'm 956 feet above the ground. Feet above the ground. So this is off a little bit before you're like, that doesn't make sense. How do I throw something from 1,000 feet up and it's less? Well, did I really find the vertex? No, I found it. Actually, what I found was this. Here was where my vertex was at 5/16 of a second, comma something more than 1,000. But then at 2 seconds, it was maybe right there. So that height would have been less. Or maybe it was here. I don't know. Maybe here. Cool? All right. So what I'd like you to do, we've got a few minutes. What do you say we do page 129, 129 and 130, evens. Cool? And I will get you your take-home test tomorrow. We'll work on that on Thursday as well. Okay? And you don't have to worry about your homework. I'm already putting the points in for you.